So in the next video, we are going to be looking at solving linear inequalities. Now, up to this point, we have done a lot of solving linear equations. And the good news is that solving linear inequalities is almost identical to solving linear equations. So the idea of adding or subtracting the same amount to both sides when you're solving a linear equation works just the same way with solving a linear inequality. Okay? There's only one thing that is different, and that is when you are multiplying or dividing through by a negative number. Okay? So, we're going to look at an example here. Let's say I write down that 3 is less than 5. We should all be happy that that is true. Okay? Now, I know that this isn't an equation to solve, okay, or an inequality to solve, okay, but we can still multiply through by numbers. We could add 2 to both sides, couldn't we, and say that 5 is less than 7, and that still works, okay. We could subtract 8 from both sides if we wanted to, subtracting 8 from the left-hand side and subtracting 8 from the right-hand side. Minus 5 is less than minus 3. True, okay? So adding or subtracting an amount to both sides is perfectly fine, okay? The inequality maintains and is correct and true. If I multiply both sides by 2, I get 6 is less than 10. That is true, okay? No problem with that. I could divide both sides by 10. 0.3 is less than 0.5. Yep, that's true. Okay, so there doesn't seem to be a problem with adding, subtracting, or multiplying by a positive number, or dividing by a positive number. What if I multiplied through by minus 1? Okay. Is that true? No. No, it's not. Minus 3 is not less than minus 5. So that's interesting, isn't it? Right? Multiplying through by a negative sign, by a negative number, seems to have got me a false statement. What if I divided through by a negative number? What if I divided through by negative 10? 3 divided by negative 10 is minus 0.3. And 5 divided by negative 10 would be minus 0.5. Now, is minus 0.3 less than minus 0.5? No, it's not. That's false. They would both be true if the inequality symbol was flipped round. Okay, so now both of these statements are true. So the statement that you get afterwards is true if you swap the inequality symbol. So multiplying or dividing by a negative number, you need to swap the inequality symbol. Okay, you need to change the direction of it. Now, when doing this, so let's say I've got something like 3 take away x is greater than 5, let's say. Okay, so here is a linear inequality. Okay, now there are 2 schools of thought here as to how to deal with this. I've seen 2 kind of like ways that people teach it. One way is some teachers tend to avoid multiplying or dividing by a negative number. It appears to be purposefully so that no errors are made in this process. which I think is a bit of a shame, because what you could do, what they would do to tackle this, is they would say, okay, well, because I've got the minus x, I'm going to add x to both sides. So I'm going to get 3 is greater than 5 plus x. Okay, so that's perfectly fine. I've added x to both sides. The inequality holds. I can then subtract 5 from both sides. The inequality holds. So x is less than minus 2. You can write it that way round. Minus 2 is greater than x, but usually we like to read it that way, don't we? So x is less than minus 2. And that's our answer. Okay? But alternatively, you could subtract the 3 from both sides and then multiply through by minus 1, knowing that when you do so, it'll flip the direction of the inequality symbol. And so this avoids this stage of what I feel is a little bit of an unnecessary step of rearranging to get the x's on the other side of the inequality. Okay? There's nothing wrong with either of these two methods. This step of multiplying, dividing through by the negative number, it's one thing that you just have to remember, that it will flip that direction of the inequality symbol.